what is it not? Because when you work with a company and you say design, they have a very ingrained idea of what that means. Okay, so when I say design to a company, they think the design of my product and service.
Yeah, that's what I thought.
Guess what? That's not it. It's not it at all. We're not looking at the design of the product and service. Okay. That doesn't mean you shouldn't consider energy efficiency in the design of your product or service. Okay. But that's not what this is about. This is about the design of facilities, equipment, systems, and processes. So, this is about the stuff you use, the buildings you're in, the equipment you have, the layout, those kind of things. What most people call facility design. So it's about the design of facility, equipment, systems, and processes. So that's what it's about. We don't include design of product in the U.S., and we're very opposed to that being included into the international standard as the U.S. Anybody want to guess why?
Energy Star's already.
We have Energy Star, that's a good point. And in Europe and in other countries, if I make the light bulb, I get to count the energy savings from the people who do the light, who use the light bulb. We think that's double counting. So we don't like that, and we don't want that in the standard. We don't want to encourage double counting. So just because I make the light bulb, I don't get to count the savings that the person using the light bulb is going to get. And in other countries, they allow that.
In which standard do they?
In their national standards, like in Japan and in Europe, they allow that. In fact, in Japan, they highly encourage that. So the Japanese are always trying to put that into the standard, and we're always going, no. So it's a perspective thing, but the very strong perspective in the U.S. is just because you make an energy efficient product does not mean you get to count all the savings the organization using the product gets. So you make an energy efficient light bulb, you get the credit for the energy savings that goes into it because of your work in your facility, on your equipment, and in your processes, not from the people who install and use your light bulbs.
That would be an oddly nightmare to document.
Yes. So we're very opposed to that being included, and you start to get the reason why.
Yes.
But it is a very strong push from other countries. But we are not talking about that here. But when you go into organizations, if they do design, they have a very strong design system in place. The most common methods for design are stage gate. It's by far the most prevalent in the U.S. You're not talking about their stage gate system. You don't care about their stage gate system. You care about what most of them are going to call their facilities process or their capital process, which is equipment, systems, and processes. So you're going to buy new stuff. You're going to buy a new press. You're going to buy a new roller. You're going to buy a new paper machine. You're going to buy a new dryer. You're going to buy a new whatever. That we care about. We care about that in the design of your system. So the water wastewater systems, when they design in and go from bubbling, instead of going to micro bubbles, they go to membranes. That's a new technology. They're buying a new technology. We care about that. We care about the energy consumption and design of that. Not only what the bringing in the new equipment's going to do, but also any of the supporting things around it and the consumption related to that. That's what we're talking about when we talk about design. So we are talking about what kind of energy improvements are we going to get through design. It's easier to design them in up front than it is to fix them after the fact. So just, putting that out there. That would be something I would encourage you to communicate. It's much easier to do it here than to fix it later. The other thing you want to think about, the two categories or buckets you really want to think about in design is your energy performance improvements. because you can get step gains from a technology change. As well as any operational activities or controls that you're going to need for that design. So just because you put in a new membrane system doesn't mean that you're operating it in the most effective or efficient manner. So it's not just what you put in, it's how you manage it once it's in. That includes, remember, operational control is not just about the buttons and how they're set, it's also about maintenance. So what I ask my CPs to do is take operational control everywhere you see it, scratch that out and put op and maintenance, op and maintenance, op and maintenance, op and maintenance, because it's a shall in there, it's operational and maintenance. So every time you see op, it's op and maintenance. So it's the operational and maintenance activities for that new equipment. Okay. So you're going to put in a new boiler. The maintenance would be, yes, at some point in its lifespan, you do have to clean the burner. Okay? You can't not clean it for 15 years and think it's going to continue to work happily. All right? It has to have some loving care. So what are you putting in? Why do you need it? And then what is the maintenance of that? Now, the other thing you need to understand in the design process is what I call optimizational exuberance. I need to put in the system, and for the system, I need a motor that is 100 horsepower. Then purchasing gets it. And the sales guy comes in to see the purchasing guy. And he goes, you know, Angie, I have this great, I know you want a 100 horsepower motor, but have I got a deal for you? I'll get you a 200 horsepower motor for the same price. And he laughs, but this happens. And then guess what? They're going, well, they told me I needed this or better. This is better. Bigger's better. And when they designed it, the 100 horsepower already had extra built into it because they only needed 80. Now they got 200. So is that motor going to operate efficiently? It's going to be sucking wind. It's going to be a very unhappy motor. But purchasing doesn't know that. Purchasing isn't supposed to know that. Purchasing knows they got something better for the same price, and you should be happy. All right? So the other part of design that is the handoff back to procurement, you need to make sure that they're not helping you more than you need them to help you. They are trying to help you, but salespeople are, kind of like snake oil salespeople. They sell what they have. They don't want to sell you the 100 because they have 60 of these 200 sitting on the shelves they got to get rid of. And they don't really care what you need. They care that they have 200 on the shelf they need to get rid of. Okay? So they're going to try and sell what they need to move. And that's their job. They're doing their job. Your purchasing person does not have the armor to understand that that's not a good decision. So a part of your responsibilities is to help the process of design, give to the purchasing people the armor that they need. So when the sales guy says, I can give you a 200 for the same price, Angie, trust me, it's a good deal. She can go, not to be higher than 150. Nope, don't want it, thank you, give me the 100. You've got, but they don't know. And
Prior
that's
to
not
today,
part-
though, I would have been like, yeah, give me the 200.
Exactly, and every
I'm
purchasing.
future-proofed in case I need more.
Yeah, exactly. And that's what your director of operations is gonna say when they look it over it. Because they look over what the engineer gave and then they put their little twist on it, which is usually ramping everything up. So then you get motors that are operating at less than half their happy load. And so they're at the unhappy load level, not the happy load level. And you see a lot of that in plants. So as you move equipment around, that's the other thing. That's why existing facilities and equipment is also a part of this process. This isn't just new stuff. So when it says design, I usually suggest you put new and existing in parentheses next to the title, because this isn't just about new stuff. You can redesign the flow of a process. This is the entire purpose of the Lean group or the Six Sigma group, whatever improvement philosophy the organization is following. This is their purpose. Their purpose is to redesign and to eliminate MUDA. Well, when they do that, they physically, when you do an actual Kaizen event, you physically pick things up and move them. Well, when you do that, you change loads. That's not a part of Kaizen. It's not a part of the wastes. Now, there are some 7 waste Kaizen systems that do include energy, but a lot of them do the standard 5 waste. That's where everybody starts, that's where everybody lays out their Kaizens based on that. So now I have moved half the stuff that was on that side of the building to this side of the building. And this motor is a very happy camper, and that motor is a very unhappy camper, because all of its load went away. They don't know better, okay? They've got 1 day to make these changes. That's the way Kaizen works. We're gonna come in, and in 1 day, we're gonna reconfigure this area, and it's going to have this new flow. They physically move it, set it up, do it. It's happy hands, lots of hands make light work, and the whole team comes in, they undo everything, they come over here, they redo everything. They have the electrician only there to hook up equipment. They don't have them there to optimize anything. That would need to be looked at by the CP to see how they're then going back and managing the design of the motor system in that particular example. It's a favorite audit trail because people don't do it. And then I can go through and say, it's kind of like shooting fish in a barrel. If I get bored, let's go shoot some fish. And we'll go out and say, okay, I see you have a Kaizen program. Can you show me the last 4 Kaizens you did? Oh, lovely. Here's a rearrangement. Let's go look at this one. Oh, I see you moved this piece of equipment, this piece of equipment. You changed out that one. Uh-huh. Energy guy. How did you address that in your design? And where's your record? Favorite audit question, it's an easy audit question, and it is a design. So don't forget on at least one of your implementation visits to go and find the continual improvement champion. Find out what methodologies they use, and find out what projects they've done in the last little bit, and then find out what you need to do to put in those energy connections. Here is a CP hint, because you're not management system folks. How far back do you have to go? From an ISO perspective, you're only held accountable to rules from the point when they existed forward. So once the organization decides to do 50,001 forward is when you are accountable for this. Now for SEP, for data, you can go back beyond your 50,001 start time, okay? That means if you're going to count projects towards your improvement that are before your ISO process went into place, you've got to go back and look at those projects for design, okay? That's the place most CPs forget. Because the process has to work going forward. But if you're going to pull any of those projects for your bottom-up comparison, you got to consider designing those too. Okay. One of the places auditors love for continual improvement is to see which of those continual improvement projects also led to energy improvements and whether or not you included them in your bottom-up comparison. Almost all of them do. Simple example. In fact, I wrote this as a finding last week. Continual Improvement Group did a rework of 3 production areas, changing the startup order, the shutdown order, and which pieces of equipment were turned off when, improving performance. But because they were changing the startup, the shutdown, and what got turned off most of the time, they were actually also improving energy performance. And it was not included in the bottom-up comparison. It's not a part of normal Kaizen activities to count energy. And they have a lot of energy activities that they do. So don't ignore continual improvement people.
So will scheduling changes like that fall under design or operational control?
It falls under their continual improvement process. It doesn't really fall within this particular lab from an organizational perspective. From 50,001, we see it in both of those areas, design and op control. But from a Kaizen perspective, I haven't changed the equipment I have. So I haven't changed the way I'm gonna operate it or the way it's maintained from a Kaizen perspective. All I've done is move it and get rid of it when I don't need it. When it's running, it should still be running at the same set points it had before, but when I don't need it, it should not be running. So they don't view that from a lean perspective as an operational change. But from an energy perspective, it is an operational change. And it is possibly a maintenance change because the run hours have changed. And it's an energy performance improvement. But that's not going to be picked up in the Kaizen system. And if you didn't build that bridge with Kaizen and get energy in there as the set, go to from the 5 to the 7, and an audit, I'm going to eat you alive.
So when you mean Kaizen, you're meaning to the lean manufacturing area and not fresh plants. Energy Kaizen.
There are energy Kaizens, it's when you go from the 5 to the 7 wastes. But most companies do not have that, and if they do get it, that they may identify, well, because we're shutting it off, we're getting rid of energy waste. They don't necessarily. The energy performance is not a construct in Kaizen, doesn't exist, but energy waste is, and you can get them to identify it if you push a little bit. But then the other thing is you're going to have to go back through those projects and see what they have. And you may have to add, you need to go back when you're doing your bottom-up comparison. That's definitely a time you want to go back, but then you need to figure out how to build a bridge in order to get them in the future to let you know so you can evaluate the energy design and op and maintenance difference. Otherwise, you're going to be in an audit and it's going to happen, guaranteed. It's a favorite auditor's haunting ground because it's an easy one to miss.
So one more question of the previous slide. So the first point, shall consider energy performance improvement opportunities during design. I know you mentioned that a little bit.
Yeah. So energy improvement opportunities in design, if you're just talking about design of the product, of course that's a good idea, but that's not really the focus of this particular area. This is more the focus of the design, energy performance improvement, and the design of the facility, the equipment, or the process. So if I'm putting in a new HVAC system, what does that do to the design? So as an example, in SEP, we had a SEP site we audited, and they did a major expansion to their building, and that changed the number of square feet in the building, but they also put in 11 new air conditioning units. So guess what that did to their base load? You put in 11 new air conditioning units. Yeah, it went up. So we needed, from an SEP perspective, to see what the operational controls were, what the maintenance activities had been designed to address those units, and what the baseline adjustments were for the month. So that's an example of what we mean by design. So we were looking at how did they design that whole process to account for both the needs from the production side of the world as well as the needs from the energy side of the world. And in that case, they actually had to add a new substation, so we also were looking at that. A simpler example,
Yeah, I guess I was overthinking that point.
yeah, it's not really that a simple example, we had a group that in Texas we audited, and they go down, like most plants, they go down every year at a set point in order to do routine maintenance. I mean, here at Tech, we do the same thing. We're shut down the week of Christmas every year. I don't care who you are, what it is you're trying to do, you will not have power that week because the facilities group shuts down. They shut down the boilers. It's when they're going to do their boiler cleaning, so there's no heat. They shut down a lot of the electrical systems. So for the labs, that's actually when they have to sometimes bring in generators to run like the nano labs, which are clean rooms, because there's no external, the building power's gone, they're going to have to run it on generators. So if you're running a lab like the bio labs or the nano labs, we have to bring in stuff to account for that. If it's standard graduate school lab, graduate student lab, get over it, pick up your experiment when it comes back, and fix the data, deal with the data issues. So yeah, they're not as important. In some companies, they have the same thing. So this site in Texas, we went in, and they had a system, and they were very proud of their fix, and it was kind of hard to explain. It was not an ideal situation. But they had a unit, a heating unit, kind of boiler style item, and it was running, and it was not a happy unit. It had hot spots. If you've ever seen one of those with hot spots, it creates holes in the outer container. It glows red, nice and red, and it's really kind of interesting. But they could not, because of what they were producing, shut down at that exact moment in time to fix this unit. It had gone bad. So they rigged up, their maintenance department rigged up what I thought was very intriguing, sprinkler hose, metal hosing, that went along the unit with compressed air hooked in to blow on it to keep it cool until they could shut down in 2 weeks. So guess what their energy consumption did during this time frame? This has been going on for about a month when we got there. So the unit wasn't efficient anymore,
Yeah.
that it had holes in it, and the compressed air usage was running 24/7 with this sprinkler system, which I thought was an ingenious use of a sprinkler. I had not seen that particular application of a sprinkler before, so I thought it was kind of interesting. But it was very, the maintenance thought they had done a great job. Do you think that's a good thing?
So they said that there was no way they could shut that thing down.
That was their answer.
What would you do in that circumstance?
Well, the first thing we said is, well, can you show me some evidence that you communicated the need to shut down?
No,
That was the first
they
thing.
might have just not. So it's going to be too hard to get permission, so let's not.
So that was the first thing, and the answer there was they had not communicated. So when I asked the question of the director of manufacturing, and he walked down there with me, he had a very different response.
Okay.
He shut it down. It was shut down, within 20 minutes. So the first place is, did you try and communicate? And in this case, the answer happened to be no. But let's say that they had, and if for whatever reason it couldn't. Okay, well then what other actions can you take? And you can, then start to look at emergency response, corrective actions that they can take to mitigate that situation. And that may have been, in that case, it may have been acceptable to some level. But even with what they had, because I asked for a picture of it when it, a month ago, and I took a picture right then and compared them just to see if it was getting worse, and it was. So there was a real risk of an emergency event. So at that point, the director of operations said, no problem going. He didn't need to see the pictures. He just saw the situation and went, shut it down, But it wasn't their call, but
Right.
they didn't, the communication wasn't there. But maintenance is a big piece of it, and in that case, we were looking at, they were going to have to replace the unit. What is your process for design to replace this boiler style item? Another example you might look at in design, some industries change very quickly in technology, other industries do not. So how often do they move equipment? How often do they get equipment from a sister facility? How often do they have a pilot line? How often do they run the production line as a pilot line? All of that are things that we get into for design. And pilot line running is a very good place to look, because pilot lines, they do all kinds of interesting things when they're running as a pilot line. That's when they get creative and see exactly what the equipment can and can't do. And they run it under conditions that are not normal. And so that's a really good place to take a look then at how is the design working, how are the maintenance and operational controls being effective. The labs are a great place to look. A lot of people and a lot of systems do not look at the R&D labs. R&D uses as much energy, sometimes more, than anybody else in the building. One of the sites we looked at, the same site in Texas, they had compressed air, so I was asking about the compressed air lines. And we were tracing one of the compressed air lines, because the compressed air line was coming in at 240 PSI, which is fairly high. And so out in the production areas, I had been asking about what the compressed air had been set at, and they had a team that was responsible for setting that at the various pieces of equipment. And the highest I had found was 80 PSI. So I was like, well, where's this 240 pounds going? Turns out it was going to the R&D lab. So they were doing some very entertaining things, including breaking a lot of glassware, but they were doing some interesting things with compressed air. Not entirely what compressed air is intended to do, by the way, but it was interesting nonetheless. They also had 2 furnaces and a number of other things, and they had a number of experiments that ran for months. They did lifetime experiments on the product. And so they were running high-end thermal equipment for months at very interesting conditions. That's an example. In that case, R&D actually had a very high energy consumption that had not really been effectively accounted for. Don't forget your little R&D friends. They hide on top levels. They do interesting things. Nobody knows what they do up there. You know, it's kind of considered the black box, so not very many people actually visit them, so they're a little odd when you do go see them, which is all okay. But for auditors, we'd love to go talk to them because they are the ones who are doing interesting things, but not for design. They design products. We're looking at how they use energy. But they are the ones that do lifetime tests, weathering tests. I had one organization who they did computer software for seatbelts. So it's software kind of thing. And so it was a 50,001 audit. Everything was going pretty well until I got to R&D. And guess what? R&D had five environmental chambers. The smallest was the size of this room. And those chambers went from minus 20 C to 190 C. It was a huge range. And they would put car seats and other car parts with these seatbelt sensors and computer pieces in it and see what happened under environmental stresses. They also had an impact tester, and they also had tests that they ran in these test chambers. So they would come and have, you know, like 100 kids sit in this car seat and see what the sensors picked up. They had huge energy consumption. Turns out those 5 environmental chambers and test chambers were on a different meter. And guess what was not in their model? So R&D can have some very interesting things. So don't forget R&D. Not for design, but for consumption. Okay. Significant impact on performance. In case you haven't figured out this is an important slide yet, we're going to show it to you again. Because energy performance improvement is what you have to be able to show. You're looking at how does the change in equipment, facilities, processes impact any of these things. So if I do a Kaizen project and I rearrange the flow of my equipment, it might, for example, impact my EMPIs. That's another place where we will check things like that. It might also introduce a new relevant variable. Here are some fun questions. Are they using the right energy source? This is a good design question. So could they use a blower or do they need compressed air? Are they doing this because it's always been done that way, or are they doing it because they made an active decision? What equipment and technology have they chosen? There's always more options. So for example, we had a question from the mining industry, and they were asking if they had to include the blasting material as an energy source. And the answer is yes. The reason is because there are a wide variety of technologies that don't require the blasting medium. So they're making a technology choice. And in this case, they're choosing to use the blasting material. What other options are there? Different materials have different impacts on energy efficiency and energy consumption. For example, there may be a process, had a company that made plastic materials. The same process, same basic output, but for two different intended uses. In one case, it's a small tube and it's used basically in any kind of laboratory situation to move material between 2 points. In another case, it's used as a medical device and as an eye drain. Same process, same material. But when it's being used for an eye drain, they have to treat that material so that the properties respond exactly the same every time. And so there are additional heat treat activities that go into the development of that tube when it is a medical device compared to when it's just a tube. So it's the same item from the company's perspective, but from the energy viewpoint, it's a very different product in those two cases, because in one case, the consumption to make the product is very low, and the other case, it's more than 5 times what it is to make the tube. Do you think that might impact your model? Yeah. Which one has a higher value to the company in terms of sales dollars? Which one costs more?
I'm sure the medical.
Medical tube does. So, they have a higher profit margin when they sell more of that. So their sales teams is tasked to sell more along those lines. But to keep the units running, they will make the tubes as well. But that's not their preferred product. So the product mix in that case did actually impact their model. And it did impact their measuring capability because we weren't necessarily picking up the difference between the two products. How do they identify relevant variables and how are they measured? Production is a good example. How are they measuring production? Where are they measuring production? Which reports are the best ones for you to get numbers from? I think Randy gave some really good examples yesterday on where you might want to get numbers from and where you might not want to get numbers from. They have a lot of numbers in production. Knowing what they are and where they came from can be advantageous. What are the NPIs? Where are they? How did they get them? Are they real measured numbers? Are they estimating it? What are they? How did they get that number? A good example is to look at production under different conditions and see if those ENPIs change. So, for example, at one of the sites, they were telling me, well, our ENPI tells us this is really going really well. And we looked at their numbers. And in one case, they were literally casting pieces for an engine, and they were also making other parts that had almost no energy consumption. When the production numbers changed so that the casting went up, the ENPI should have indicated that, but it didn't. And it turns out that their electrical meters went, so the processes went that way down the facility. Their electrical meters went that way down the facility.
I don't know.
So if I'm running more in the casting and less in the little parts, you would want to pick this up. But since their meters were running this way, it didn't pick up all the parts of that casting line. It only picked up this part on one meter, that part on another meter, and that part on a third meter. But on the little parts, which were running this way, each one of these lines was little parts. So every time the little parts went up, consumption went up, but it wasn't, this isn't my heavy energy use. This line is, but my meter is going this way. It can make a difference in your numbers. It can make a difference in how you understand the process and what needs to be in your model. Design happens in numerous cases. It can happen because you are trying to improve something. It can happen because somebody's trying to correct something. It can happen because of a Kaizen event. It can happen because of a new product. It can happen because of a regulation. There's any number of reasons that can trigger a design. I think you probably got that. All right, so what do you need to do? You need to find the facility people, you need to find the continual improvement people, and you need to find a way to find out when there's been a change. So that means the purchasing people, which hopefully you now have a good relationship with. So how can you get the system to create those flags when new equipment is brought in, even if it's new to the facility but not brand new? So for example, transferred from a sister facility. How do you find out when they're doing an improvement action and moving something around that might change the way and the loads on various pieces of equipment? That's going to come from your continual improvement folks. And what about new products? That's going to come from your R&D folks. The other one that's not up here, of course, is your R&D and pilot line activities, and that's another one you really do need to check on, because they can be, they could be nothing, they could be a lot. If they have a strong design process, they may want to kind of blow you off. We already have this covered. This isn't stage gate. This isn't about what are the stages your product goes through to get designed. That's not what this is. But they may have a strong capital process that you can leverage. They may have a strong continual improvement process that you can leverage. You may have to do design across multiple processes. There's not going to be one place that's going to give you all the different issues within design. There's not, it's not the product from conception to pilot. It's changes in facilities, equipment, systems, and processes. Records are your fun challenge. What are the records for those different types of design going to be, and where are they going to be? That's usually not in place, so that's a fun records challenge. So, things that you will have for design. What is the outcome of that design? Is there a change in energy performance? Is there a change in a specification needed? Is there a change in operational or maintenance control, which is missing from up here? It should also have that bullet. Because you might have a change in operational or maintenance activities. The other consideration here is who's doing it. This may be now something that a contractor is running. So don't forget, contractors make changes all the time. So don't forget to include the contractors in this activity. All right, so now we're going to have you review the process that KRM currently has in place and decide what's what. Is it good? Is it bad? Would you be able to use it? Would you be able to leverage any of it, or do you need to start over? So what you want to do is look at what they have, decide if it meets any of the requirements of 50,001, if it addresses any of the areas you have to address, and if not, what areas are missing. I don't want you to rewrite it or redo it, but just kind of a hit list of who you need to go see, a hit list of key things you think are missing, if there's anything missing. And then one thing you can leverage. You got to find one positive thing. Okay? General practice when you're working with an organization, you try not to go in and say, well, this is a complete redo. You try and say, well, there are a few good things and there are opportunities. You don't crush them every time you walk in the door. It's not a generally good plan. So find one thing you like, even if it's not meeting a requirement, find something in there you like.
This pink color is really nice.
There you go. Or it could be, lunch was very good every day. It's one of those. But find something you like, and then is there anything you can say, and if not, what are the key areas you need to address? And it won't take you 30 minutes. It'll take you probably 10. But we'll see where you are in about 15 or so.
I have just a quick question.
So if you're helping a facility establish a baseline and get through the initial process to get SCP certified. So let's say you're on year 3 and everything's tracking great, right? They're getting this great energy reduction and the performance is fantastic. They're moving right along to silver. And then something changes, like environmental regulation that requires some crazy new control that sucks their energy use, and Next thing you know, they're tracking where they're not gonna make it. So in that situation, can you go back and change their baseline and justify it so that they can still show a
Until-
reduction?
Until the stage 2 audit occurs, you can change the model. You can shift it around however you want. You submit a model
But
that you're.
still stay on that same track?
Mhm.
Okay.
Yeah, you submit a model 6 months in advance with your application. It tells the auditors what to look for, what pathway you're going to do.
Yeah.
You know, what kind of model you're using so that they can have the right competencies available to do the audit. At stage 1, they just confirm that that's still the case.
Mhm.
So if they got there in stage 1 and you said, yeah, well, we've changed our model, we're doing X, Y, and Z now, they may need to make some minor adjustments. And that's what stage 1 is about, confirming information. At stage 2, they actually audit it. So as long as you tell them at stage 1 what you've done,
Sure.
you shouldn't have a problem.
So they would be pretty reasonable in that situation and recognize that if that equipment would have been in 3 years prior in the baseline, you still would have presented a 5% reduction.
Yeah,
Okay.
it's not that bad. Now, if you don't tell them and they get surprised at stage 2, it will not be a happy day.
Sure.
But as long as you make those changes and adjustments and let them know,
Okay.
you shouldn't have a
So you
problem.
can change your baseline
Yeah, you can
if
shift it
it
around.
makes sense.
Yeah, you can shift it around.
Okay.
And a lot of people, I mean, will submit one model at their application and then, you know, right at stage 1, like 24 hours in advance of stage 1, they'll send